Oi, Keshav, I need Shushankita on call. Just go in there outside of it.
Mail, sir.
Where?
Top right.
Next
Mail.
up.
Just reply and
Hello, much. Jimmy sir is there. 1 second.
Let's go. Okay.
You have to just click on go live. No?
वहाँ पे.
Always.
यहाँ पे. Says like
Click on live.
so just have to change to 101.
When you're in this, you click somewhere else and then press to go online.
So one will be just okay. Hello everyone. Welcome to Robotics 102. My name is Sujay. I'll be the host for this session today. So today I'm thrilled to have you all join me. Today we're going to learn about the ultrasonic sensor. Am I audible for you guys? Okay. You can't hear me? All right, very good. All right, good. Yeah, you can hear me, right? So before we actually dive into the session and learn about ultrasonic sensor, we will first look into my voice is low. Yeah, we can hear you. All right, yeah. Some of you are telling my voice is low. Some of you are telling you can hear me. All right, yeah. I'll take with the majority. You guys that hear me. Try increasing your volume if you can't hear me. All right. So before we dive into the session, I have a announcement to make of the contest we ran in the Discord channel. We had a challenge, right? So there were a lot of submissions. I'm very happy that you guys are submitting. And you also, in the previous live session, you also got points. Yes, in this session also you will get points, but you'll get double the points since our delay and all this. So let's see about the submissions. Let's see who all have submitted. So before we see ultrasonic sensors, yeah. So let's start with the basics. Can anybody tell me what an ultrasonic sensor is? On the comments. What is an ultrasonic sensor? Yeah. It's used to measure distances, correct, Advik? Sense obstacles, yeah, that's one way. Let's out radio waves for communications. Is it really radio waves? Sound waves, somebody says. Okay. So if you can see my screen. So this here is an ultrasonic sensor, right? So this is used to measure so many things, basically measure distance. Before we see how to measure distance using an ultrasonic sensor, you see this desk in front of me, right? So how would you measure this desk? Can I use my hand to measure it? Okay, if I use my hand, let's say I'm measuring like this. Let's say I'm measuring like this. So if I use my hand to measure, my hand is bigger than yours, probably. So I have a big hand, someone will have smaller hand. So is that, yeah, somebody says a scale, a ruler. So let's take a ruler. Let's take this ruler. So I'll have to measure this. Now one, now again I'll have to go like this. Then if I miss it and go, then that's a mistake. So what can I do? Okay, use a scale, all right. Okay, I have something. I have a huge scale. Now I can measure the whole table. Will this work? Yeah, it's a meter rod. Yeah, it's 1 meter basically. So yeah, measuring tape. Yes. So now if I ask you to measure your room, you will have to use a measuring tape, correct? But what is the disadvantage of using a measuring tape? What's the disadvantage of using a measuring tape? Can anybody tell me? So I have a tape here. I can use this. Yeah, of course, but I'll have to measure a room, a huge room. Not accurate. It is I mean, not that accurate, but it can be accurate. Can measure. But if I'm holding one side and then I'm going here, I want somebody else to hold it, right? And tell me what is the distance, the room. I want two people, correct? Yeah, there should be two people, yes. Now, if I don't have two people, what do I do? Yeah, okay. We'll use the ultrasonic sensor. So I'll show you a couple of projects which are made by using ultrasonic sensor. Based on that, we'll see what it can do. So this is a small project. I hope you all can see the screen. So let me connect it to power and let's see what it does. Can you guys name the components here? Can you guys tell me what components I've used here? We've connected an LCD to an ultrasonic and done some coding to find distance. So yeah, very accurate, Darshak. Yes, I've connected an LCD display. This is an ultrasonic sensor, and I've connected to the Arduino. We've given it programming. We've done some programming. Okay, so let me fix it. So now I hope you can read the distance. Now if I place my hand in front of it, it's changing. Now it says it's at 9 centimeter. I move it away, it keeps increasing, right? And if I move it closer, correct? So now what is this doing is it's measuring the distance using ultrasound. So how is it doing that? Can anybody tell me? Okay, eco, what is eco? Arduino board using LCD. Okay, I'm asking how is it measuring? How does it know this is 12 centimeter? Sending a ping. Okay, so many different answers. Yes. So yeah, most of you are right. It's sending a ping. Okay. For those who don't know, I'll tell you what a ping is. Basically, there are two parts of this sensor. So if you can see here, there is a T and there is a R, correct? So T will transmit sound. Basically, it will give out sound. So like I'm speaking out now, you can hear me, right? So it will give out sound, and R will receive. It's like your ears. It will receive. Yeah, transmitter and receiver. T is transmitter. R is receiver. So this sound which goes out of the transmitter will hit a object and come back. If there's no object, doesn't come back, right? So it's similar to throwing a ball at a wall. If I throw a ball at a wall, the ball will hit the wall and come back, and I can catch it. If there's no wall in front of me and I throw the ball, it just goes away. It doesn't come back to me. Same way, the same logic with the sound. So it is very nice thing. It doesn't have to be. It can measure anything. It can measure a wall in front of you, a hand in front of you, a wooden piece, whatever you keep, a glass piece, anything. But since it's sound, it'll always reflect and come back, right? So that's there. So let's see another project which we have with us using the same sensor. Okay, you guys can see this, right? So you guys can see this. Can tell me, anybody tell me what is it? So I turned it on. There's an ultrasonic sensor. So what is it doing basically? I'll turn it off. Yeah. So what is this doing? It's an obstacle avoider car, correct? It's using a battery. It's yes, I have a battery pack here. It has an Arduino, it has an ultrasonic, and there are a couple of motors, and there's a motor driver. I'll tell you what the motor driver does. Basically, it distributes the power and controls the wheel. So the direction of the how the motor spins, left or right. Yes, it changes the direction. So I've written a small program to make it go. If there's a obstacle which is there, it'll go either way, right, left or right. You can program it. I'll show you one more project, one last project, and then we'll make one of these. We'll build one of this together. So this here you can see. Okay, I'll turn it this way. This here you can see. Small project which we made again. So I have a road like place. So I have a toy car. Let's say I come here, it opens, then the car passes and the gate closes. So it's a toll gate, right? Yeah. Yeah. You guys did it. That's great. You guys made it. So yes. So basically it's sensing once the car comes, and once the car goes out, it waits and then closes the barricade. It's a toll gate, yes. So let's make this toll gate. Are you guys excited to make this toll gate? I'll tell you how to build it, what goes behind it, and the programming, all those things. Okay. So yeah, let's start with the basic thing which I need for the toll gate. I will need Arduino and ultrasonic sensors, breadboard, of course, to put the sensor on, and some wires. All right. Okay. So let's connect it. Okay. For those of you who've seen the ultrasonic, yeah, let me zoom in a little. Yeah. So for those of you who've seen an ultrasonic, yes. Let me share you the screen so that you can see. Yeah. So that's an ultrasonic sensor. It has 4 pins. It has VCC, trigger, echo, and ground. Correct? So can anybody tell me what is VCC? Okay. VCC is nothing but power, giving it power, and ground positive. And ground is negative, correct? And then trigger and echo are 2 different pins. Okay. So when I say it's trigger, it's basically I'm sending out signals. I'm triggering something. So basically I'm triggering it to send out the signals. And when I say echo, when will you hear an echo? When do you usually hear an echo? Okay. So echo, yes, when the sound comes back to me, right? When the sound comes back to me, I will hear an echo. All right. Yeah, receive is echo, correct? So these are the 4 pins. Now let's see how to connect them. Um, I will put this thing on a breadboard. So let's say this way. Okay, that's in. So I'll need 4 wires for it again, four different pins. These are called jumper wires. Makes our connection with ultrasonic and any other components easier. So now, this, the rightmost pin will be VCC. So where does VCC go on the Arduino? Okay, VCC goes, where does VCC go? Anybody? Digital pins, okay. Any other answer? Why digital pin? 3v3. Okay. Okay. So 3.3 volts, yes, either or 5 volts. VCC is nothing but power, right? So I can give it to either 3 or 5 volts. Let me give it to 5 volts here. Okay. And then GND, of course, that's the last pin. Okay, GND pin. So now I've connected a black wire to GND. Okay, this is a black wire which I've connected to GND. So where does it go? To the GND pin. Yes, correct. Now 2 pins are left. So let me tell you what I've connected. The purple I'll get connected to trigger, and the gray one I'll connect it to eco on the breadboard. Now let me connect the purple and the gray one on the Arduino. So let me connect the purple one, the trigger pin, basically the trigger pin, to pin number 9, and then next to it I'll connect the eco pin, pin number 10. Okay, very simple connections. Yes. Okay, after this we'll switch to the Arduino to write a program for it. Okay, so everybody can open their Arduino IDE. I'm sure you know how to open their IDE. Let's see how to write this program. So initially there are a couple of things. As soon as you open, there are 2 things on your screen that we'll come back to that. So first, we've used 2 pins, of course, which I right now told trigger and eco. So first you have to tell the Arduino we have used 2 pins. So let's say in, which is trig. Okay, trig is equal to what pin we have connected, trigger to 9. Okay, then int. Why are we using int here? Anybody? What do you think? 1 minute. 3 Are you not seeing my screen? Are you not seeing my screen? Okay. 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 Hope you're seeing my screen. Now, what is the other pin? Eco. I'll just write pin so that I don't trigger. So this will be 10. These are the 2 things we are using. Okay. Now let's come to the first thing. Okay. It says void setup. You put your setup code here and it runs only once. That's what it says. It runs once. So whatever code runs once, we have to put it here. So I'll tell you serial dot. You can't see ID. What screen are you seeing? I am in top down screen. You're supposed to see ID. No? Good. Okay. Alright, we're good. We can see the ID. Now we'll return serial dot begin 9600. So basically we're telling the setup. So there is a serial monitor and the band of 9600, and we are using that monitor to see values. So we have to start that monitor. Okay. Now there are two pins which we've used, right? Now we have to tell what does this pin do. Okay. So which is the first pin? Trig pin. So what does this pin do? Is it an output or an input? Yes, it's an output pin. Similarly, we have one more pin, which is I can copy paste the same thing. Okay, that is not trig, but that is echo. Now, right? So we have two pins, trigger and echo, correct? That's it. Anything else we should put in the setup? No. These are the only things which you need to run once. Everything else we need to run it repeatedly. So if we want to run something repeatedly, we'll come to the void loop and write the code here, right? So in the void loop, what do I write? Okay, initially, now we know these pins 9, 10 are what kind of pins? These are digital pins, so we'll have to give a digital signal to it. Digital, sorry, what a digital. Mhm. Okay, if you can't see my pins, doesn't work. Okay, let me zoom it so that you can see the screen. Those who think the text is small, you can do this on your computer too. Okay, better? Can you see it? Or should I increase more? Let me increase it to 20. Okay, all right. Now we'll do a digital write. Okay, then we'll do first just trig. We'll have to trigger the, so we'll initially set it as low. Low means it's off. There's no signal going to it. And we'll give a delay. Delay of microsecond will give. It's a small delay, basically. Okay. So we'll give a 2 microsecond of delay. Now in what happened? Okay, you can use my screen. Okay. Now after the delay, I'll have to set the trigger pin to high. So basically I'm setting it as like a pulse. I'm turning it off for wait for 2 seconds and turning it on. So what do I write? What do I write? Anybody tell me? Anybody knows? How do I set it to high? Okay, digital write again. All right, can I copy paste this? All right, digital write, and I'll have to make it high. Okay, perfect. Now I'll have to wait again before I turn it off. So I'll use the same function. Let's wait for this time. Let's wait for 10 microseconds. Sorry, 1 0. Okay, we'll wait for 10 microseconds. Okay, now I'll have to turn it off. Okay, so that's a complete on to off. So this way, what you're trying to tell us, send a signal, wait, and turn. When you wait, first it'll be off, then you turn it on, wait for it to go and come back, and turn it off. All right. So we give that delay for that to come it out. When you give it continuous delay, you don't know which sound is coming back, right? It will be continuously coming back to you. So we'll have to wait for some time. Okay. Now, okay. Now, what else we have to measure? So we'll have to now see when this pulse goes, when the sound goes and comes back. Now we have to know the time it takes. Correct? So we'll say long. Long is another data type. It will say a big number basically. Duration. So duration is the we have to see what duration it takes for the sound to go and come back. So there's a function which is built in again. It's called pulse. Pulse in. Okay. Now pulse in. So which is the pin that receives this signal? Okay. Echo pin. So if it receives the signal, what kind of a pin is it? Is it an input or an output? Is it an input or an output? Okay. So it's an input. So here we'll have to write input. We've written it as output. Now, so if it's an input pin, we'll have to activate this pin so that it can receive. So I'll say high. If I say high, this pin turns on and starts receiving. Okay. Now we have the duration. Now high, know how much time the sound takes to go hit an object and come back. Now I have the time taken. Okay. So as soon as it goes, it finds an object, hits and come back. So I have that time in the variable duration. Now, how do I just with the time can I calculate distance? Does anybody know how to calculate distance? Okay. Distance is duration. Anybody knows how do I calculate it? Time by speed. Okay. Multiply 330 meter divide by 2. Okay. So many of you different answers. Okay. Why do I do that? Why should I? What is 340 and all these things? So, like I said, ultrasonic is sound, right? It's a sound. It uses sound waves. Now we need to know how fast the sound travels. Anybody knows how fast the sound travels? Okay. Speed into time. Okay. So yeah, distance is speed into time, correct. But how fast is the speed? I'm asking about 340. Yes, 340 meter per second is correct. So it's very fast. It's 340 meter per second. So let me give a fun fact before I tell you. So if you've seen fighter jets, they travel at a really fast, high speed, basically. So once they reach a speed which is higher than 340 meter per second or approximately 340, higher than the speed of sound, and that time you will hear a loud sound from the jet. It's called a sonic boom. Hence the word sonic is related to sound. Ultrasonic, basically whatever sound we hear from this sensor, you can't hear it, right? So sonic is basically sound, speed of sound. Okay. All right. So yeah. So we need to find distance now. It's another integer. Let's say distance. Okay. Now duration we have time taken into okay 343 meter per second you guys told, but now I want it in centimeters because I'm not measuring meters, right? I want centimeters. So how many centimeters is my hand from the sensor? So for that, what can I do? What can I do? What can I do? Anybody? No? Okay. Okay. All right. So can I write it as 0.034 in centimeters? What is 343 divided by 1000? Okay, how much is 1 meter? How many centimeters is 1 meter? Anybody can tell me? 100 centimeters, correct? So, yeah. So if I divide 343 by 100 or 1000, okay, 1000 basically. Okay, 0.034. Okay, now I'll tell you by 2. Can anybody tell me, so many of you told by 2. Can anybody tell me why I'm dividing by this distance by 2? Anybody knows why we're doing it by 2? Correct. Yeah, yeah, correct. So the distance is basically going and coming back, right? I mean, the sound waves is going and coming back. We only want the distance from here to here. We don't want it twice. So yeah, that's why divided by 2. Now we can print it. Can anybody tell me how we can print it? The serial monitor? Any? How can we print it using the serial monitor? Yeah, what is the command I should write? What is the code that I have to write for it to print? Serial digital print. As a digital print, we want to use the serial monitor, so it will be serial.print. Okay, so I will first print distance. Now if this is there inside the double quotes, which means it's exactly printing what is there inside the double quotes, right? But I have to print the value which we've calculated. So let's say serial dot print again. Now what should I write here? Distance is the variable, correct? So this would be dot last thing serial dot print. And what units is this again? What units is this? Centimeters. So we'll write cm at the end. Okay, so this is in loop. Now here we'll write a small wait time of okay, I've connected the Arduino to my laptop through the cable. Let's select the board. It says Arduino Uno. So I've selected. Let's upload the code. Click on upload. Okay, there's something which we missed. Yeah, we missed a semicolon. So even if you have an error, it'll show you It's also showing you which line before delay. So we've written a delay here. So we'll have and compiling. Okay, done uploading. So now how do we see the output? Where do we see the output? On the Arduino, but we did not connected any display. We've not connected in the LCD display, right? So we'll have to, yeah, somebody sold serial monitor. So we'll click on serial monitor. It's on the right top corner next to this wave like thingy. There's a magnifier like icon. So if you click on that, you will get a serial monitor. Now we are getting some values, but we've told 9600 is the band. So we'll go to 9600. Then here, let's reset the code and run it again. So basically you're getting 160, 160, 160. So yeah, so what is happening is it's not getting a new line, right? So if you write in the code ln, it'll go to the new line. And let's give a small bigger delay. Let's give 1 second. That's 1000. Let's upload the code now. Perfect. Let's clear scale. Yeah, we're getting 160 centimeters. Now let's see if I place something in between. Yeah. Okay. Okay, let's see. So I placed my hand, so the value is changing. I'll move it over. It's become 14, 16, 19. Let me bring it closer. 6, 8, 7. It's 7. Further. It's 14. So it's changing. So this is how you use an ultrasonic sensor to connect to an Arduino and then control it and see the values. All right. So let's see another component with it right away. Let's see what else does the tollgate need apart from the ultrasonic sensor. It's okay. We'll extend 10 more minutes. That's not an issue. Yeah, it's baud rate. Yes, you guys are right. It's baud rate. So 9600 is the baud rate. We need a servo. Okay, very good. Let's see how to control the servo. Okay. So we have a servo here. Let me show you the screen as well. I have an image of it. Yeah, I do have an image of it. So servo is this tiny thing. It's a motor, of course, and it has 3 wires, not like a regular motor which has 2. This has 3 wires. So usually it has 3 colors: brown, red, and orange. Here also it's brown, red, and orange. So brown is always GND, which is ground. Red is always positive, which is plus 5 volts, and all red is PWM, or sorry, orange is PWM, which is signal. Basically, we call it a signal. Yeah, PWM. So you know what PWM is? Do you guys know what PWM stands for? Anybody knows? Correct. Yeah, PWM is pulse width modulation, which is absolutely right. So there are certain digital pins on your Arduino which are PWM pins specifically. So if you can see the pin number 3, 5, 6, 9, and 10, this on your Arduino. If you guys have an Arduino, it will be a small squiggly line. Okay, I don't know if I can do just to show you this. Okay. Can you guys see this on the screen? Okay. So on these or on this Arduino, there's a small squiggly line. You can see it on your Arduino as well. You guys, these are PWM pins. Basically, they give you pulse signals, just like how we used the 9 and 10 was pulse, right, for echo and trigger. So 9 and 10 are PWM pins. It'll give you pulse signals. Okay. Okay. So let me remove this connection. So let's see how I'll connect the servo to this. So, I mean, before we connect, can anybody tell me why we use a servo? Why not any other motor? Okay, to control angle, yes. Why do we use a servo? My question is why we using the servo? Precise movements, yes. So yeah, we need precision movements, right? In a toll gate, it has to stand like this, and then it has to stand in 90 degrees. So yeah, we need control the degree of rotation, correct? All right. So now, like I told, the brown pin is always, what is the brown pin? The brown wire in the servo? GND, very good. Okay, I'll connect it to the ground. And the red will be, what is the red pin? Okay, 5 volts, 5 volts, 5 volts, yes. Positive or 5 volts, yes. And that's it. The last one will be orange, which is again the PWM or the signal. So I'll connect it the first available PWM pin from starting from 0. It's 3. 0, 1, 2, 3. So that pin number 3, I connected there. Perfect. Very simple connections. Okay. So now we'll see how we can program this. So let's go back to this one. Okay. Let's say new. Okay. We'll open a new sketch. Now, before we start, so this servo has something called as a library. So when you're writing some code, there are some functions which are very big to write and you don't have to keep repeating it. So we'll have a library which is, so whoever made this servo motor, they have their own libraries. So we will include a library. How do I include this? Ash include. So there is a bracket. Okay. And then you give you a list of libraries, then servo.h. So servo.h. Okay. So this is the library. Now, once you've created the library, you have to create your servo. So let me call it my servo. Okay. All right. So these are the two things you have to do. On the setup, what do I do? Again, serial monitor. I don't have to write any output. If I have to write any output, we'll write the serial begin. Okay. We'll get 56 done. Okay. Now I have to tell the Arduino which pin my servo is connected. Okay. My servo is connected. So it's connected. So how do I tell it is there's a function called attach, attach. Okay. Now I'll say 3. So now I've told the program my servo is connected to 3. All right. Now, initially I want my servo to be in 0 degrees, so in the beginning position. So how do I write it? My servo again dot right, and then I'll give its angle. So let's say 0. This is my setup. So my servo is connected to pin 3, this line, and my servo should start from 0 degrees, the angle. So now that's it in the setup. And what do we want to repeat? Okay, from the 0 degrees, let's put it to 90 degrees. So it's the same code again. Anybody tell me what code it is? We've already written how to set it to a different angle. Can't see my screen. Can you all see my screen? Digital right? Yes, yes. No, digital right. We just wrote it, no? What? How do I set it? Now I set it to 0 degrees. How do I set it to 90 degrees? Same thing. My servo dot right will do 90. And we'll wait for some time. Let's say delay. Delay for how many seconds? Let's say 2 seconds. Done. Delay for 2 seconds. Now shall we put the servo back to 0? Okay, we'll put the servo back to 0. Then we'll give another delay. Smaller delay. Done. This is the code. Okay, so we're setting it to 90. We're waiting for 2 seconds and setting it to 0. Let's see what happens. Let's select the board, Arduino from 15 and upload. Okay. So you can see it's going to 0, 90 and 0. So leave this. Can you all see this? Okay, if I have to change something in the program, let's say I'll do this as 180, then upload the code. So you can see it's doing a 180 turn. Correct? So got it. Now we know how to do this. Now we know how to control. Yes, it moves as per the angle. Okay. So now using the ultrasonic and these, the servo will combine the code, both of the codes, and then we will see how to make a toll gate, which is this, which I've already connected, right? So yeah, so in this code, let me copy paste the previous code. Okay, so this was my code for the ultrasonic. So let me take this we'll combine. Just this small bar cut. Okay, it's back. Yeah. Okay, so I've copy pasted this one, and also I have to copy paste the loop from the same thing. There's no difference. We'll do all this. So yeah, so now the servo and the ultrasonic code is both here. Okay, let me take this. Okay, the loop, we have the ultrasonic code. Now there's a small bit of code which you have to write. Now what do I write is, so when will I toll gate get open? Can anybody tell me when will it open? When the ultrasonic senses an obstacle. So it can sense an obstacle here also, here also. Let's say this is approximately is 10 centimeters. Okay, yeah. So let's, if the distance is less than 10, correct? If the distance is less than 10, then I have to do something. What do I do? My servo, yes, I have to do something to my servo. Should I set it to 0 or should I set it to 90? If it's less than 10 centimeter, that is, if it's in this distance, should I set it to 90 or 0? So this is 0, this will be 90. Yes, 90. Okay, my servo dot write is 90. Dot write is 90. Okay, now the gate will open. So as soon as the gate opens, what should I do? What should I do next? Yes, why is there a delay? Why should I give a delay? Anybody can answer. Delay is correct, but tell me why I should give a delay. Correct. So the car can go by that time. So we don't want the gate to hit the car and then damage the car. So we'll say it'll take 2 seconds for me to pass the gate. Now what should I do? Close the gate, of course. So in that case, again 0, and we'll wait. Yeah, it's for it to stay open for a while is correct. So yeah, so this delay here, we'll put it at last. Okay. So now that we have the code, let's upload it. It's already uploaded. Let's upload it again. Yeah, it's working. So if I get the car here, you can see as long as there is a car there, it will keep open. But if I pass the car, it will immediately. So we'll do that again. See, as long as there is a car, it will still be open. As soon as the car passes, it will close. So isn't that a cool project? So I hope you guys understood. Do you have any questions? Do you have any questions for me? Okay. So yeah, like how the challenge was given to you, and I showed you 4 challenges, right? So I've selected 4 challenges, and now I'll tell you before I announce the winner of the challenge. There are a lot other challenges which will be posted on the Discord channel. So stay active, participate, and then wait, don't go. I'll tell you who the winner is. You can see me, right? Yeah. So yeah, before I tell you the winner, there'll be a lot of challenges and a lot of giveaways like this. So do participate and actively participate in the Zenbot. Keep an eye on the challenges which we post. Submit your projects, and who knows, you can be the lucky one to get a giveaway or whatever. So yes, so this whoever is getting this today. Are you guys excited? Who do you think it is? Okay, somebody will get this, but which of the four? So it's who's it? Is Shiva there on the screen? Shiva, are you watching? Shiva is the one who won it. He made a 4-way traffic light, which is from this amazing. So this goes to Shiva. We'll send it out to him. And there's many more coming like this. So do participate. On the Discord channel. All right, Shiva, this is yours. This goes to Shiva. And one more will be sent out next month. So we'll post a challenge soon on the Discord channel. Yeah, Shiva is from OIS Nigdi. Okay, we'll post the challenge soon on the Discord channel. Please be active, participate, and then get your chance to win all these things. All right, thank you guys. Signing off. See you in the next session with some fun projects. Hope you liked it. You have any questions, you can post it on the Discord channel also. We're all on the Discord channel. We'll try and solve your questions. You're making any project and you need help, we're all there on the Discord channel. Hope you guys have joined the Discord channel, and do let your friends at Orchids to join the Discord channel as well for robotics. Yes, Darshit, you have a doubt. Yes, tell me. How will he get his surprise? I will send it to him. I know which school he is in. Sir, I tried the same, but the servo motor responds lately. What would be the problem? Respond lately? Okay. Did you try changing the pin from any other pin, any other PWM pin? Try it from 3 or 6 or 5. Okay, yes, Sanjeev, you also have a question. What is your question? Yeah, you also try the same thing. No, try it with a different pin. Try it, if you've tried it with 3, try it with 5, 6. Try reducing your delay. How will he get his gift? I will send it to his school. That's how he'll get his gift. Okay. All right, we'll connect back in the Discord channel for the doubts. We'll end the live session here. We'll join. I'll be on Discord live and online, so you can as well. All right, and post your code also if you have a doubt in your code also. All right. My name is Sujay. I'm on Discord. All right. See you guys. Thank you.